Hey there, everybody. Sorry I had to duck out of campus today, so in lieu of that, I will, as briefly as possible, walk you through some of the material for today. The first thing you need to do is go to the Brightspace page, go to sample data files, that module. The link at the bottom says where to download our data. So hopefully you've done this already, but if not, you go here, you can click download, you can click this URL, either one will download our data for you. It gives you a giant folder called Names by State. Now what I want you to do is take this and move it to your desktop. You can keep it elsewhere if you want to, but all of my code assumes that this folder is on your desktop. If you want to keep it somewhere else or you're using Colab and you can't get that to work out, please let me know. But I already have it on my desktop somewhere here. Names by State. Okay, so let me briefly show you what this data looks like. There are a bunch of text files in this folder. These are all straight from the Social Security Administration. If you open one of them, so this is Alabama. Let me make this bigger. Okay. Each line in the file corresponds to 1 year in Alabama, a given name, a given sex assigned at birth, so this is F for female, and the number of babies like that. So what this is saying is that in Alabama, in the year 1910, there were 875 babies born given the name Mary, assigned sex of female. 232 Maddies, and so on. So this is a complete record of baby name data from the state of Alabama starting in 1910. So if you scroll through here, 1910, 1910, you have to scroll for a while. Here's 1911, 5 Zolas. Okay, scroll, scroll, scroll. Keep scrolling up to the 1970s now. It'll go all the way through 2024. And then goes back to 1910, 1920, whatever. And now it's giving you male baby names. So 1921, 31 babies named Guy. Very generic. Guy. Okay. Lloyd, spelled with one L, 31 of those. So this is what our data looks like. It's broken down by state. It's a record of the number of babies with a given name and a given gender born in a given year in a given state. Now there's one caveat to all this, which is that suppose in Alabama in 1921, there was like one kid named Apple or something, kind of an offbeat name. That kid's name will not appear in this file. The minimum number you will see here is 5. That's as low as these counts go. Let's see. So down to 876, 5. Okay, 5, 5, 5, 5. And then jumps back up for the next year. So they do this for privacy reasons. So in a given state, if there are fewer than 5 babies born with a given name, given sex, then it won't be recorded in this data. So this is not a complete record of baby names in the United States since 1910, but it's as close as you can get without worrying about, one baby here or there violating their privacy because their name is unusual. Okay, so that's what the data looks like. So we have that data for a bunch of states, every state. So now we can think about what kinds of questions we want to answer about this data, and the kinds of questions we'll answer are things like, what's the most popular baby name in a given year? For a given name, like David or Corbin or whoever. What did that name do over time? In Idaho, right? Like, what's the deal with Corbins in Idaho? Were a lot of them or not? Were there a lot back in 1920? Were there a lot in 2010? Things like that. So I'm just going to quickly run you through some code that gets some basic data crunching up and running for these files, and we will hit these much harder all week after Thanksgiving, or at least 2 of the 3 class days. Okay, so if you now go to the Brightspace page and go to data analysis sample code, I've already preloaded a bunch of code from this data analysis SSA day 1. So you can grab that and follow along with, again, the caveat that names by state folder, for me, it has to be on the desktop. So see how there's a desktop right there? So if you want to keep it in your downloads, you would change like that. You have to give it the file path. You might be able to just drag the folder over here. So maybe if you're in Colab, you might be able to do that, in which case you will get rid of this desktop like that. There's so much data here, though. I'm not sure. I don't want to do it on mine because I don't want to take up all that space. It's something like 100 megabytes of data, so it's not, inconceivable. But anyway, you might try dragging over here and seeing if that works. But for me, on my desktop. Okay, anyway, so here are all the libraries we'll need. We'll talk about what these do as we go, but pandas is familiar to us. Matplotlib lets us plot basic things. This OS will let us go through the files one by one, things like that. So we'll talk about it as we go. Okay, so now the first thing I want to do for real, so I've already run this cell here, see how it ran. So now I'm going to read in the files state by state. So what this OS library does is it goes to a given folder you tell it to go to, and it just reads the files that are there. So let me show you what that looks like if I run this. So it knows in.txt is a file in that folder. For you, the files might be in a different order. I don't know how it decides the order here. Like notice it's not alphabetical, so I don't know what it's doing. But Indiana.txt, that's the Indiana data is in there, so on. If you scroll down, notice there's this PDF. This PDF just has the information I outlined for you in there. We don't care about that PDF, so we'd want to filter it out. But at the very least, this OS library, that's what it lets you do. This line of code, you can point it to a folder and say, hey, check out all the files that are in that folder for me, please, and read them in. So I've done that, but then like I said, there might be garbage extra files you don't care about, like that PDF. So you can do this filter thing here, which just says, hey, if you see anything that looks like something, the star is just a stand-in. So look for files that look like something followed by .txt, and then just give me those. So now file names contains all the files we actually care about. There's no more PDF in there. Okay. So if at this point, since we're not in class, I can't look at you or whatever, if something has gone wrong for you already, it's probably because you did not put this in the right place. Like you didn't put it on your desktop, or if you put it over here on the left, you didn't erase this desktop thing. You just got to make sure Python knows where this folder is living, this names by state folder. And like I said, in Colab, I'm not totally sure how it works. You can probably just drag the folder over here if you want to, or maybe you can tell Colab how to access your desktop. But if you're in Colab, the first thing I would try is dragging all this over here, seeing if it'll accept all of it, and then taking this desktop thing off. Okay, but anyway, even if that didn't work for you, you can have me look at it when we get back. The logic of the code doesn't care though, so let's just continue with the sample code. So I'm not going to play with all the data for now. I'm just going to read in a single file. So let's look at Missouri data, for example. So I'm going to open a single file. I'm going to use this .readcsv command that we've seen before, make it into a pandas data frame. And notice, even though it's not a CSV file, it kind of is. So let me show you. Like a CSV just stands for comma separated values, and see how these are values separated by commas. Right? So you can read in this data using the read CSV command. The thing is though, other files that we've read in as a CSV have column names. So there's spreadsheets where the top row would be like state, and then sex, and then year, and then name, and then number or count or something. So these files don't have column names. But if you want to use pandas to its fullest extent, you need column names that you can reference. So here, notice I'm just creating, and I can call these whatever I want, but these seem like the most natural names: state, sex, year, name, number. So I can open this file, give it these column names, and then now I have a data frame that looks like this. So this is Missouri data, data mo. And again, you can call this whatever you want. I'm trying to give it a name that is suggestive so we don't forget what it is. But this is my first official data frame. So I've read in a single file for Missouri with these column names. And now I can do whatever I want. And so notice, by the way, this file is very long. So if I do like this, there's 150,000 lines in that file. Okay, there's a lot of data, right? Essentially every baby that's been born in Missouri since the year 1910. So these first 5 lines are, right, only the first 5 of 150,000. Okay. So now we can, like, there's all sorts of stuff you can do. So, like, as always with data analysis, the question is, well, what do you want to know? What kind of things do you want to look for? So the first thing I did when I was naming my kids, thinking about my kids' names, I wanted to give them names that weren't super common, but also not super uncommon. So for my oldest daughter, we settled on Annalise, and I actually did a bunch of this analysis we're going to do in class before she was born, just so I get a sense of how frequent her name is. Anyway, so you can go into this data frame, data mo, and you can do this kind of slicing like we've done before. Just say, hey, I want the name inside that data frame to be Annalise. Slice that out for me. So now I have this data frame called data mo Annalise, and it contains every Annalise hit in Missouri all the way back to 1910. These numbers on the left, by the way, are just the row in the data frame. Like, see how data frames come with row numbers? So you can just ignore these numbers on the left. They're not telling you anything. But, you know, 1989, 5 Annalises, 2005. So there are some. There's enough to get registered in this database, but there's not that many. So if you want to see, like, well, okay, I don't care about the 1990s. Maybe I care about, my daughter was born in 2014. So like always, you can sort a data frame by a given column if you want to. So I will. This will sort from 2024 down. So my daughter was born in 2014. So she was one of these 19 Annalises right here, born in 2014. So after 2010, there's, like, you know, not a lot, but a reasonable number of hits. It's no Jennifer or something, so it's not super common, but it's not super uncommon. You can also sort by number if you want to. So notice these numbers are jumbled because I sorted by year. So let's sort by number. So notice in Missouri, my daughter was born in, like, the peak year for Annalises. 2013, 2014, for some reason, was like, those were the banner years for Annalise. So my wife and I did not know this, but we participated in some sort of minor supercharged peak year for Annalises. Uh, anyway, and notice none of these top numbers are from the 1920s or something. So this was not a particularly common name before for the 19 whatever 80s or something. So if I tell it to show me 35 rows, I'm not sure. Yeah. So I don't even get any hits before the 1980s. Looks like 1989 is the first year. Yeah, anyway. All right. So there's something you can do. You can slice by name and then see how popular that name was in a given year. What was the, like, most popular year for that name in your state? You can do things like that. So right now I'm just showing you, like, a grab bag of things you can do. And then when we come back from Thanksgiving, we will have more focused questions we will look at. But the point of this cell is to show you, like, well, in a given year, let's say 2020, a good year, right? Everybody liked that year. That was the year my third kid was born. You could ask, what was the most popular Missouri name in 2020? So now I'm going to go into the data mo data frame and slice out the year 2020, not the name anymore, but the year. And then I can sort by number and just see what it says. So here are the 5 most popular names in Missouri in 2020. Stratified by sex here, right? So there might be some female Olivers, maybe. Those female Olivers don't show up in this 345. So we'll talk later about how you can combine male and female if you would like. It's conceivable, I guess, that there's some, you know, like maybe some female Noahs. So if you add female to male, this number might rise some. But anyway, here's just the most popular when you keep the male and female separated. So Oliver, Olivia, Liam, you know, my daughter's class, daycare class, she was born in 2020. My daughter's daycare class has like 2 Liams. She has a Charlotte in there. I think she has like 2 Williams. Okay. So this tracks for me. She definitely had an Oliver at some point. Anyway, so here's how you can just look at the most popular names, keeping male and female separate. If you want to do any of this for a different state, then you would just come back up here, and instead of reading in data mo Missouri, you know, if you're from Colorado or something, just change that to Colorado. Change that to Colorado, and then just rerun all this code. I'm sticking with Missouri for now. Okay, what's next? All right, so this list has both male and female. Suppose you only care about male names, then you can again do some data slicing. So you can slice out the year 2020 and slice out male like that. So now I've created a data frame that contains only babies from 2020, only designated male. Okay, and then sort by values, same deal. And I guess this is just showing me I already knew this, I guess. There were already 5 here, but whatever. Here's the 10 most popular male baby names. Theodore making a comeback, right? That's kind of an old-timey name, but my daughter's class also has a Theodore in it. I grew up with no Theodores when I was growing up in the late 80s, early 90s. Okay. So moving on. You can plot things if you want to. So you could ask, like, over time, what's the deal with the name Taylor? So, like, let's get a visual of the number of Taylors from 1910 to 1911 all the way up through 2024. So all I'm going to do is slice out from the, and this is in Missouri still. I've done nothing at the national level yet. I can slice out Taylors, and I did this equals name right here, so I don't have to type there. I can type there. Doesn't matter how you do it. But anyway, you just slice out, and here's the most basic plot command you can do. So I'm not going to, like, this doesn't create a fancy plot. It doesn't give labels to the axes or anything. Just the bare bones basic plot. Plot year against number of Taylors. So let's run this and see what it says. All right, so here's a plot of Taylors over time, stretching back to 1910-ish, all the way through 2024. Notice this plot is strange. There are 3 curves here. I actually don't know what this line is. Okay, I'm not sure why it's plotting that. If we were in class, I would ask you, what do you think this curve is, the taller one? What do you think this shorter curve is? And I'm sure somebody could come up with an answer. The answer is the taller curve is the number of female Taylors, and this is the number of male Taylors. But, like, you didn't tell it to think about that. It's confused because it doesn't know, like, it doesn't know to combine those or if you want them combined. So it just plots everything. So if you want to be like, oh, oops, okay. Well, just show me female Taylors. Then there you go. There's the taller one. So actually, there's no record in Missouri before 1980 of female Taylors. That used to be a male name predominantly. So again, there may have been some babies named that before 1980, but there would have been fewer than 5 and therefore not included in the data. So if you want to graph female and male together, here I've juiced up the plot some. So you can make these plots as fancy or not fancy as you want, but now notice there's way more stuff, but like all I'm doing is adding a title, giving labels to the axes, I'm putting a legend on there, you know, whatever. So you can remove these or add these as you want. But now I'm slicing out female Taylors, I'm slicing out male Taylors. Those are 2 separate data frames, each with their own number counts. And then I'm just labeling, very stereotypical here, right? I should have been more creative maybe, but now the pink curve will be female Taylors and the blue curve will be male Taylors. And now it gives me this nice little plot. And again, we see there's no pink before 1980. So any hits you're getting before 1980 are still not very popular, but there's some record of male Taylors in Missouri going back to 1915 or something. All right. So anyway, here's some basic plotting you can do. Do you want to visualize what Taylors do in Missouri or not? You want to visualize what like David does in Missouri or not? So, oh, there are some female Davids between like the late 50s and the 90s, I guess, right? Interesting. All right. Anyway, so David in Missouri had his heyday in like 1955 or something, it looks like, and then it's been slowly tailing off ever since. Notice I didn't change the name of the plot, so it still says Taylor here. So if you wanted to make all of this automatic, you would do like this. Like that. So if I change the name up top, it gets changed right there. Why didn't it let me do that? Unterminated literal string. What are you talking about? Oh, do I have to make the quote marks? Yeah, sorry. I can't use single quote here and double quote there. Anyway. Interesting. I wonder, David is a very male name. I wonder. Once you start playing with this data, it's hard not to just mess with it. Yeah, so there were some female Matthews, for example, also. There was a stretch from like the 60s to the 80s, I guess, where people were trying to make these male names slightly more female. I don't know. Okay, so that's how you can plot two separate curves on the same set of axes. And you can do this for like male and female the same name. You can, if you want to, like you control what these data frames are. So these, for me, these are female and male, in this case now Matthew data frames. If I change it back to Taylor, that's what it was. But you could like make this data frame be Taylor's and this one be David's, and watch Taylor versus David if you want to. Whatever. You can do whatever you want with these plots. You can change the colors, change the labels, so on. There's a lot you can do. Okay, so now, what if you don't care about male versus female? Suppose you want to combine them. So I'm going to go back to Missouri. I'm going to slice out Taylor. I'm doing this fresh. So I got this thing called data name that contains all Missouri babies named Taylor, male and female also. And then check this statement out. We've seen this in the election data stuff, but it was used in a much different way. In the election data stuff, we grouped the voters together based on if they had the same opinion. So if I ranked the same candidates in the same order as you did, we grouped me and you together. Now we're doing the same basic thing here. So now in a given year, so in 1920 or something, or 2000, we want to just combine the male and female Taylors. So what we want to do is, in a given year, I only have, since I've already sliced Taylors out, right? My data frame consists only of Taylors and years, basically, right? And gender. So just go to a given year, and then whatever numbers you see, add them together. That's what this is saying, dot sum. So let me just say that again. In a given year, all we have are Taylors now. So like in 2020, there's male Taylors and female Taylors. So when we say group by year, we're saying go to a year, and every number you see in that year, add it up. That will then combine male Taylors and female Taylors, because you're telling you just add them up, whatever you see. And then we can plot it. So again, here's the most basic plot command. Although I think above I was using this syntax, it doesn't matter. So I switch back and forth because I forget what I like better. So if you like the syntax that we've been using everywhere else, you can switch it. But anyway, now notice it gives you just a single curve, and it peaks out at 800 right here. So if I go back up and look at the, where was it? Okay, here are female Taylors. So that peaks at 600-ish. So this new curve peaks at 800-ish. So whatever year this was, 1990 or something, there were 800 Taylors combined. So I don't know, 600 female, 200 male, something like that. So here's how you can combine male and female if you want to. You have to use a group by command. So group by, and in this case, it's by year. I want to go year by year and just add male and female to each other. So add up the two numbers. There are other ways we'll use group by later, but for now, this is how you can do that. So I want to end today by showing you, well, if you leave the state of Missouri and you want to just read in all the data as a single data frame, okay, every single state as its own, and then combine it into one frame. So you have all the data in one place. I'm calling it data. Here's how you can do that. So we've already seen this before. I showed you this up top, so we don't need to rehash what that's doing. Filtering out non-text files. And then these files don't have column names. So I have to get a data frame up and running, I have to tell it what the columns are called. And then check this out. I read each file like this. So I go to desktop names by state, and then for a given state, in file names, so like indiana.txt, missouri.txt, and whatever. It doesn't need a header, whatever that means, don't worry about it. I'm telling it the column names are these. So for every state in file names, read it in, and then check out this command, concatenate. So that means just like all 50 or 51 of those data frames, I guess, because DC, I think DC is in here. Maybe it's not. Well, DC is in there, right? So there's 51 data frames. So concat just says, hey, scrunch them all together into one. So this data now is a national data frame. Every single baby from all the 51 states plus DC are in there now. So I can read that in. And I want you to notice, see the star here? It's thinking. That's a lot of data. So it still only took it like 2 seconds, but it was not instantaneous. And there's 6.6 million lines in this data frame. That is a humongous spreadsheet. Microsoft Excel would have trouble opening that. It might crash. But Pandas, it does, like I said, it thinks for a second here. It's like 2 seconds, but it reads it in, and now it's going to do computations for you just fine. This is one of the advantages of Pandas. It's very powerful. But anyway, so data.head, let me show you what that looks like. The other nice thing about Jupyter Lab is that you don't have to keep rerunning. Once you run this cell, data, you can use it in future cells without having to read in all the data again. So the data is like locked in. You don't have to read it in again and wait. Anyway, so it read in Indiana first for whatever reason. So Indiana's in there. If you want to know how many babies are in this data frame, let's see. What would that look like? Okay. How many babies are recorded in this? You can ask it, look at the count column inside data, add it all up. It's going to take a second to read in. I don't know. Oh, oops. Sorry. It's not called count. That was what we used when we were doing election stuff. So I get confused. Number. Okay, so how many is that? 328 million babies are in this database. That's a lot of data. Okay, so now let's finish by using this national data frame and answering, again, a pretty typical question you might want to know. What are the most popular baby names in whatever year? I picked this at random, 2006. Okay, and now notice, I just want to know the most popular baby name. Forget about male versus female, whatever. Right? So for each name, what we should do is combine male and female and then see what's most popular. So I go to the national data frame, which I call data. I slice out by the year 2006. And then here's that same group by command from above. And now, because I've already sliced by year, I don't have to group by that anymore. I'm within 2006. But now I'm saying, hey, for each name that you see, so in 2006, right? There's Taylor's, there's Matthews, there's David's, there's whatever. For every name you see, you're going to see it twice. You're going to see David male, David female, Taylor male, Taylor female. And again, just add up the numbers that you see. So just again to emphasize, I don't have to group by year here because I've already plucked out the year I care about. If you group by year, it's not going to do anything here. Now it's saying find the name you want and group. There's 2 entries like that in 2006. And then sort by number, false, ascending equals false. So from biggest to smallest. Okay, so here you go. In 2006, these were the 10 most popular baby names. Jacob, Michael, Joshua, very biblical names dominating then, and then Matthew. Oh, okay. You might notice, by the way, that these are almost all male names. So Emily is the only female name. There's sort of this interesting phenomenon nowadays that wasn't true in the 1920s, but male names tend to be less diverse than female names. There just tend to be more female names floating around that people are willing to use, and so people don't converge as much on female names nowadays. So they're just, for whatever reason, there are fewer male names that people tend to use, so we get these clusters. So only one female name cracks the top 10. And if I do this for, I don't know, I guess 2006 is around when you people were born, right? So, I don't know. We don't have anybody named any of these in our class, right? So we totally missed out. But it's sort of fun looking at, old-timey. Like in 1920, what was the deal? If you go back far enough, Mary just dominates. Okay? Mary was a very popular name long ago. And so now let's see, how many female names? 1, 2, 3, 4. All right. So there's still more male names in the top 10, but not as many. So people were sort of Male and female names were almost equally diverse back in 1920, I guess. But these are some classic old-timey names. Margaret, Helen, stuff like that. Anyway, sort of fun just to check. So like my parents were born in 55. Mary, no longer dominating at the top, but still in the top 10. Deborah, all right. Linda, okay. Anyway, so you could, if you wanted to, you could separate this out by gender. We already did that above for Missouri. Same thing for nationally. Okay, so there's more sample code in the file that we were going to go over today, but I'm going to stop here because I don't want to take too much time in a video. So like always, if any of this is confusing to you or you couldn't get it to run or whatever, please don't hesitate to email me. I will be checking email over break fairly frequently, so make sure you reach out if you want to talk about anything.